So today we have planned to go for load balancer theories. Okay. So I think yesterday I have not shared you the notes. Maybe in that note I need to add something more. JKL. So what exactly is a load balancer? So load balancer will be a device. In real scenario, when we talk about it, it is a device. It is available in all the data centers. Okay, data center means the place where we have the devices which process the data, which stores the data, that is called data center. So in every data center, whether it is for government organization, it is for private organization, they will have data center, and definitely they will have the web server. And if they have the web server or any application server, like we are using the apps in our mobile, so how these apps work? So when we do anything here, it goes to the app server, application server. App in short is application. So it goes and connect with the application server. So suppose, just for an example, all of you are using Facebook apps. So Facebook, Instagram, these applications is going to connect somewhere. You are using your banking application. Again, for that also there will be some server. So the organization, the company for which you are using this, there will be application server. Now, based on the customer, number of customers, they will have number of servers in the backend with the same database, with the same configuration. Okay. So if they have multiple servers, just take an example. I have 5 servers for the same application. So as my customer, on which server you will try first? Which server you will send the request first? It will be tough to take a decision that which server is free. Also, if I say to the customer that there are 5 servers on my data center, if you want to use my apps, you change randomly and check which one is free. Then what will happen? The user will not connect. They'll move to some other company. So I will lose my customer. Okay, because everyone wants flexibility. So to fix this problem, I need to place a device called load balancer as a mediator between the application servers and customer. Understood? So application, this load balancer will be working as a mediator. So it will listen the request from the users. So whatever number of users you are, just come to me. I will forward the request. And load balancer will know the status of backend server, that which one is free, and accordingly it will forward the request to the servers. So load balancer is created just to do the load balancing. So there are many type of load balancer available in the market. Okay. So yesterday you have seen here we have the gateway load balancer, we have the application load balancer, like that type of options and name you have seen in AWS cloud. Okay. So let us understand the concept. First, we are going to see the concept of LLB. LLB stands for link load balancer. So it is also a type of load balancer. So we can say it as a gateway load balancer here in this AWS. And in real scenario, when you go in the corporate, we say it as a LLB, link load balancer. So what is the use of this link load balancer? As you know, every company nowadays is having more than two internet connection. Okay, they will have two internet connection. And why they will have two internet connection? Because if one internet connection goes down, They will not wait and call the customer care that my internet is down, please come and fix. Meanwhile, they will have loss in business. In corporate, they cannot wait, they cannot stop the business for few seconds even. In few seconds only, they will have lot of business loss, revenue loss. So they want things to run continuously. That's why they have lot of alternate options. So one of the alternate options we have is multiple ISP links. So how these things are connected? So suppose someone has taken connection from Tata Telecom and Airtel both. Two internet connection is there. And this is my LAN switch. And these all are my PCs. Okay. In between there will be other devices also, but just showing the traffic flow, like how it goes from your laptop to the internet. Okay. And just place one more device in between, that is our firewall. Okay, so this is what our firewall, and this one is our LLP. So how does it work? So you have two internet connections, so you will set by default all the users should access internet via Tata. If Tata goes down, automatically the traffic should go to Airtel. But you know one more thing, in your computer there is a one thing called gateway. So gateway IP address is configured. If gateway IP address is not configured, you will not be able to access internet, or you will not be able to communicate with other network. So suppose if LLB is not there, then what will happen? I have to give IP address of Tata router as a gateway, and when the Tata is down, I have to immediately inform everyone, please change the gateway IP to Airtel router. Understood? So it will be also very big problem. So what we do, we use LLB. So we give LLB IP address as a gateway IP address. So all the traffic goes where? LLB. LLB will continuously monitor which link is up, which link is down. So the link which is up, it will forward your internet request via that link. So that is the use of link load balancer. Then you will say, what is the meaning of load balancing? Here it is only forwarding to one, and if one is down, then it is going to another. It's not like that. You have the option. If you want to use both at the same time, you can use. Means one traffic for one user, it will go from here, another user, it will go from Airtel. That option also you can configure. You can also configure that internet access should be done from Tata, and voice data means in call center you see they will call through the internet. So voice data should go via Airtel, or any other type of traffic. I want to specify that this traffic should go from this ISP, this traffic should go from another ISP. So these things we can do, we can define with the help of LLM. So these things are clear. So that's why we say it as a gateway load balancer. Which one will be the gateway? Using which connection it will go? That is defined in LLB. Any confusion? Clear how it works? So when we use LLB, if someone is going to ask you when we use LLB or gateway load balancer, so what you will say? When we have multiple gateway device or we have multiple internet connection. If they ask you multiple gateway load balancer, then you can say when we have multiple gateway. Or when they ask you when we use LLB or link load balancer, then you say when we have multiple internet connection. Clear this point? Then only we use it. If I have one internet connection, then there is a no meaning of load balance. So this concept is clear. Now coming to the next, that is called SLB, server load balancer or application load balancer. So next type is called SLB, server load balancer. Okay. So how this server load balancer works? So as I told you, we may have multiple servers, okay, in our network for the same application. And there will be one user sitting on internet and he want to access your service. So he has to try first this server, second this server, third this server. So user cannot do like this. So what I am going to do, I am going to place one device called SLB in between, server load balancer. So now the user is going to send request where? On SLB. So user will think that SLB is my server. Understood? User will think SLB is my server. I am asking from the server. But in the backend, SLB is not a server. SLB is simply a forwarder. SLB will listen the request and forward the request or distribute the request. That's it. So this is the work of SLB. Now what we do to do the load balancing, because in network we can have multiple application. So we will create a group, different groups per application. We will create a group and we will add the server which belongs to that application in that group, and then we connect it with the SLB. So what happens? The request comes from user on SLB and then goes to group and group is going to distribute. So here if you see, there are multiple terms called virtual service. So virtual service means IP address and port number on which user will connect. Understood? So this is what virtual service is, simply a combination of IP address and port number on which user is going to connect for the service. Okay, and this IP address will be registered where? In the DNS. So that's why when you type www.google.com, then it is resolved in the IP. Then this IP goes to the firewall, and from there it convert and comes to the SLB. Then after this, you define what? Policy. So this is the relation: virtual service, then policy, and this is what you create: group and method of distribution. Okay, and these all are what? Our real servers, or you can say actual servers. So how the flow works? We receive the request on SLB, and using the policy we defined that this request I have to forward on which group, because I can have multiple application, and for every application we are not going to create separate load balancer or purchase separate load balancer. So on the same load balancer there can be multiple application servers detail. So when the request comes, it will forward the request to which server. So that's why when you go to any hospital, there is a reception. In which department you want to go, they ask you and they direct you that go this side, go this side. So similarly, this SLB is going to do. When the request comes, it says what is there. So what it has to check, that is defined in policy, what it has to check and forward to which group. So we define in the policy. So it matches the things in the request and accordingly it forward to the group. And then what group is going to do? It is going to distribute based on the method. So what type of method we have? So let me show you some visual of the same. See here I can show you, but what will happen? It will not show in the recording. If I put it in presentation mode, na, it will be complete black in the recording, so you will not be able to see the animation. So just simply understand that one method is called round robin. So round robin means the request will come to the load balancer, and load balancer as per the policy will forward to the group. And in group, if you have said that among these all server I will distribute using method round robin, then first request it will forward to real server 1 or A, then second request to real server B, then third to real server C, and fourth to A, fifth to B, means one by one to all. So this is the one method called round robin. Next method we have list connection. So in the list connection, what happened? This load balancer will know that which server is having least number of active connection. So every server will have lot of requests in the queue in the pipeline. So it will check which server is having less number of requests and the next request will be forwarded to that server. Is it clear? So in that way, it is going to distribute the request. I hope this one is clear. Any confusion? Now coming to the theory as per AWS. So elastic load balancer is used to distribute user request on available backend server based on the load balancing method. So we have two methods, round robin and list connection. So round robin sends one by one to each instances, and list connection send request to instance on which number of active session or request is less. Now the next is elastic load balancer can be public or private, depend on the subnet you choose. So public and private you understand very well. Like I want to create a load balancer for my employees only. My application server, my CRM server, my SAP server, SAP server, these all are accessed by my employees and I want to do load balancing for them. A database server they are accessing, I want to do load balancing for them. Then I will create private elastic load balancer, and when I am doing for public user, then I will do public load balancer. Is it clear? Next is used to distribute incoming traffic. So always keep in mind, application load balancer is going to do load balancing of incoming traffic, not for outgoing traffic. Incoming traffic means suppose I am the server and you are sending the request. So this traffic is called incoming traffic. Okay, for my network. For your network it will be outgoing. For my network it will be incoming traffic. And load balancing can be done only based on the incoming traffic, not for the outgoing traffic. But same case, if we think about LLB, link load balancer, it does load balancing for which type of traffic? Incoming or outgoing? Outgoing traffic. Because from LAN it is going outside and then it is distributing the traffic on multiple internet connections. So that is outgoing traffic load balancing in LLB, and in SLB or application load balancer it does for incoming. Okay. Those are registered. Registered word means what? Registered word means membership. So when we create group, target group we have created yesterday, then we add servers or instance as a member. So instead of using membership word here, we are using registered. So we select the servers and then registered in the group. And it does the health check of instance. So health check means what? Every 5 seconds or whatever number of seconds you are going to define during the configuration. Generally every 5 seconds, 3 seconds, based on the application behavior or criticality, we define this health check. So what happens in health check? Every 5 seconds it will send a request. Which will send request? Load balancer will send request to the application server. Like yesterday we have selected the method of health check HTTP, means it will send HTTP request to the load balancer and sorry, the real server, and real server will respond back with the HTTP response. So if request response is happening, it will think server is up. If it is sending request and server is not responding for 3 times, it will mark that server is unhealthy, server is down. And when the request comes, it will not forward to that server because server is down. So this is the advantage of health check. Suppose if health check is off, what problem will happen? Hmm? Some user will get the service, some user will not get the service. Because the work of load balancer is whatever request come, it will forward to the server, but it will not make sure that server is responding or not. Understood? So server will, a load balancer will forward the request to the server. And if it is not checking the health, even the server is down, it will forward the request. But when we set health check, the advantage is if server is down, it will not forward the request to that server because load balancer knows the server is down. Understood? If an instance is unhealthy, Elastic Load Balancer stops sending traffic to those instances. We can move our web server to private subnet, only keep load balancer in public subnet. What does it mean? So, as you have seen lot of scenarios in cloud, this is what VPC. Inside the VPC, you have created 2 subnets. Okay. This is your public subnet, private subnet. Okay. So what does that statement means? After that, the internet gateway and route table you know better. So it says that you can keep your servers where? In private subnet and load balancer in public subnet. So what is going to happen when a user from internet is trying to access the service? So your VPC is connected to internet, and as you know, by default, public and private subnet are also connected inside a VPC with each other. Means all the subnet inside the VPC will communicate with each other by default. So if I set things like this, what is going to happen? The user will send request to load balancer because it is in public, directly it can reach to the load balancer. And now load balancer can reach to the server or not. It can reach. So that is what it is saying. Instead of keeping these servers in public subnet, we can set it in private subnet. So always the request will go via load balancer, not directly to the server. If they try to target also, they cannot target. Understood? So this is the concept behind that. So you can keep it. Another advantage, if you keep it in the private subnet, you will not use the public IP. And definitely when you are not using the public IP for this server, the charges will be low. Okay. So same thing they are saying here. So elastic load balancer in public to receive the request from client and send the traffic to private instances. Okay. So this was the concept of load balancer. I hope you understood. So only the concept is you have to understand three things. One, load balancer. Second, target group. What is the function of target group? And health check. These three things, if you understand properly, you can work in this load balancer easily. Target group, based on the number of application, we will create separate target group. Okay. And here we are creating separate load balancer. What is the reason behind that? Because here we are not taking as a device. In real scenario, if we are purchasing as a device or we are creating an instance for load balancer, then internally we create multiple target group, not multiple load balancer. Instead of that, we are creating virtual service on which the user will connect for separate applications. Okay. So target group means group of application server, health check to check the health of instance, and load balancer to connect the service by the user. Okay. So always as a troubleshooting, you check load balancer should be active and your real server should be healthy. If it is not there and you are trying to access the service, you will not be able to access. Now, where is the use in the real scenario? In the real scenario, we are going to create in a different way. We are not going to use this load balancer in this way. In the real scenario, what you are going to do, you will create auto scaling. Behind the auto scaling, there will be load balancer, and behind the load balancer, there will be multiple servers. So these three things works together. Without that, there is a no meaning of auto scaling. What is auto scaling? Suppose you have created two instances today in the load balancer. Today your customer is 500. Your business goes well. Suddenly your customer came 10,000, and your servers are capable of handling up to 1,000 customers only. Then these all servers will be overloaded and maybe hacked and maybe shut down also, or maybe crash also your applications, because huge load came, the traffic came on your server. So what you are going to do, you will create one more server. Okay. You will create 2 3 servers, but you don't know how much exactly is the request. You will track, so you don't have idea. You are tracking, and accordingly you are going to create multiple servers, but meanwhile your entire customers are impacting. Suppose you are working for Flipkart and the competitor is Amazon, and this is the big billion days. So if you have to purchase, suppose, a fridge, so first you will go to Flipkart and you will see, oh, it is very huge traffic there. The application is not opening, not working properly. Website is not opening. So you will do one thing. Okay, wait. Let us go for some snacks. Meanwhile, the server will become open, and their administrator will add more server. Then I will try again. Will you do that as a customer? You need a fridge. So you will not be loyal to Flipkart. Immediately you will switch to Amazon. And if Amazon server is working, then you will do purchase from there. It is like open market. If you need anything, you go to any shop, and if that is not available on that shop is closed, then definitely you will move to another shop. So same thing happen here. So business will impact. If you are doing the manual approach, manually adding the servers. So for that, the solution is auto scaling. Another problem with the manual approach, I will tell you. Suppose you have added the server, then it is your responsibility to remove the server when it is not in use. Else you will be charged. Okay. In the real scenario, in the normal data center, if you are going to have multiple servers, if you are going to purchase a server computers and all, then today you will think five server I will purchase, that is enough. Your business grown. So again you are going to purchase in the market, it will take a lot of time. So for the same solution you came in the cloud, but again the manual approach takes time. And in cloud also, after you suppose big billion days finished, you don't have traffic on those servers, so you need to remove it, else you will be charged for that server. And if you are busy, suppose 2 3 days full of bills, so the solution is auto scaling. So what does auto scaling does? You will define some criteria that if the load of server increase to 70%, start adding the server. And when the load of server reduce to 30% or 50%, start removing the server. So that is called a scale in and a scale out policy. So you will define the policies. So you don't need to sit and monitor the server. Whenever the load increases, automatically there is a tools uh, called CloudWatch for monitoring the services. So it will monitor the service instance, and when it found the load, it will start adding the server, and when it is not there, it will remove the server. Now I said auto scaling if you are going to do alone, what is the advantage? Today you have created server in the auto scaling and you have configured everything. Suddenly the load increase. What auto scaling will do? It will add 10 servers. Suppose to fix this problem, you have used custom AMI. You remember custom AMI? You will prepare one server, do the cloning, and you will say auto scaling, I want this type of server every time. So auto scaling will create 10 servers. But how the load will be distributed on all the 10 servers? For that, what we need? Load balancer. So without that, we cannot use load balancer. So both has dependency with each other. If you are using only load balancer and your traffic is fixed, as a private network, you know I have 500 employees means 500 employees. But in the public environment, you don't know when the traffic will hike. So there we need auto scaling along with the load balancer. Only load balancer is not going to fulfill our requirement. That is why first we have seen how the load balancer works. Now in the next session, we will see how to create auto scaling and we will see the behavior of auto scaling, and then later we will connect both. Understood? So this will be our approach. Any confusion? So next class we will have auto scaling. So tomorrow is what? Friday. In good weather, most of people will have health issues to sleep. Okay, so I have shared theories for both. So tomorrow we will do practical of load balancer directly. And one more thing